There are few places on Earth where people do not need to be concerned about flooding. Any place with rainfalls is vulnerable. A flood occurs when water overflows or inundates land that's normally dry. This can happen in a multitude of ways. The most common is when rivers or streams overflow their banks. Excessive rain, a ruptured dam, or levee or ice rapidly melting in the mountains create so-called floodplains. Most floods take hours or even days to develop, giving residents enough time to prepare or evacuate. Others generate quickly and with little warning. These flash floods can be extremely dangerous, instantly turning a babbling brook into a thundering wall of water and sweeping everything in its path downstream. Disaster experts classify floods according to their likelihood of occurring in a given time period. A 100-year flood, for example, is an extremely large, destructive event that would theoretically be expected to happen only once every century. But this is a theoretical number. In reality, this classification means that there is a 1% chance that such a flood could happen in any given year. Over recent decades, 100-year floods have been occurring worldwide with frightening regularity. Moving water has an unfathomable destructive power. When a river overflows, its banks and structures are usually poorly equipped to withstand the water's strength. Bridges, houses, trees and cars are picked up with ease and carried off. Even though on the 26th of November 2007, the European Union published a directive with an aim to reduce and manage risks that floods pose to human health, the environment, cultural heritage and economic activity, this has not helped us in June 2013. Waters from 3 swollen rivers gushed into the old town of Passau in southeastern Germany on Monday as officials warned that water levels, already in the highest in 70 years, could rise further. The city was one of the worst hit by flooding that has spread across a large area of Central Europe. At least 8 people were reported to have died and 9 were missing due to floods in Germany, Austria, Switzerland, and the Czech Republic. Most of Passau was inaccessible on foot, and the electrical supply was shut down as a precaution, an official said. Rescuers were using boats to evacuate residents from flooded parts of the city. But with water coming from the Danube, Inn, and Ilz, rivers relentlessly pouring into the city, water was advancing into previously dry streets and in one case going from dry to ankle deep within half an hour. Nations come together to mitigate and redirect inevitable floods, which have resulted in some of the most ambitious engineering efforts ever seen. Highly advanced computer-engineered innovations let authorities predict where floods will occur with amazing accuracy. Our project serves this purpose. Everything starts with a flood warning coming from one of many measuring stations spread across the nation. The signal for the first danger level, which is yellow in this case, prompts 2 out of 8 pumps to start pumping water out of the river through underground pipes up in order for them to start. The pipe ends are embedded into concrete to ensure stability. The electricity to power up the pumps comes from a diesel generator, which is also charged with energy from the water flowing through the pipes. The river water is sucked into the pumping station through a larger pump, filtered to the quality of industrial water, and finally streamed through special Pelton turbines. They generate electricity, which is also responsible for powering a part of the plant. The electrical power, which is not primarily required, can either be charged into the electrical storage device or it can be led into the power grid as a form of output. The river water finally ends up in a reserve pool or so-called drain basin. In case the measuring station reads out a stronger flood surge, the warning is signalized with either an orange color alert and prompts 4 pumps to start working, or a red color alert, in which case all 8 pumps are utilized. If the water level of the river sinks, the drain basin is prompted to let the water flow back into the river. In times of low flood risk, the system can be used to supply inexpensive industrial water or water for fish farming. The connection to the river ensures fresh water in the fish tank, since the power needed for the exchange of water pumping can easily be sourced from the electrical storage device. Usually, there are several pumping stations near the river so that there are enough catch basins to process the excess water in case of even the most surprising floods. Since the system automatically and responsively compensates for any increase in the river's water level, floods can effectively be prevented. Therefore, the people living in the vicinity of the river are protected, and the economical damage can be avoided. Flooding is the most common of natural disasters, causing billions in losses for governments and homeowners. What we propose here is a relatively inexpensive, environmentally safe solution. Our project provides an early warning system, correct risk assessment communication, and implements preparedness for the communities on how to face disaster.